again, we're going to continue with what we have started in the last video. I'm going to give you more examples related to ln x and the derivative of ln f of x. Example 3. Y equal ln x squared plus e to the power of x. We need to find the derivative of this function. So I can write the derivative of y as dy by dx. Then derivative of ln of g of x. Derivative of ln anything is 1 over that thing. And this is a composite function, so I have to multiply this with the derivative of whatever between the brackets. So the derivative of x squared is 2x. Derivative of e to the power of x is e to the power of x. Then we can multiply the 1 with this, so it will be 2x plus e to the power of x over x squared plus e to the power of x. Of course, the mistakes that I'm sure that no one of you will do it, is to cancel out e to the power of x or to cancel out the x. We cannot do that because of the plus. Okay, this is example 3. Let us have another example. Example 4. Example 4 is the classic question. If y equal ln x squared over 3x, find the equation of the tangent when x equals 1. Again, we have done this many times, and it is a classic question. This question is in every test, every evaluation, those kinds of questions. In order to find the equation of the tangent, the first thing we need to find a point on the tangent. This point, when x is 1, like let's say the graph of this function will be something like this. I don't know. It will have a curve. We don't know how it looks like. I don't have a graphing calculator now, and I didn't graph. But the idea is, I want to find the slope of the tangent when x is 1. So probably when x is 1, it will be here. And we need to find the equation of this line. In order to find the equation of any line, we need two things. We need a point on the line and the slope of the line. The point of the line, we just substitute with x in the equation because this point lies on the line and lies on the curve. So we can get y from the equation of the curve. So to get the point y when x is 1 equal ln 1 squared over 3 times 1, which is ln 1 over 3. ln 1, we said that ln 1 means e to the power of what gave us 1, that is 0. 0 divided by 3 is 0, so the point has coordinates 1 and 0. This is the point on the line, okay, on the tangent line. The second thing we need to find is the slope of the line. The slope, in grade 9 we used to have 2 points and we get the difference in y and the rise over the run, the difference in y over the difference in x. In grade 12 we use derivative to find the slope, because the slope will equal y prime or dy by dx when x is 1. So I need to find y prime. The derivative, this will be quotient, so it is 3x squared, low d high ln x squared is 1 over x squared times the derivative of g of x, which is x squared, which is 2x, minus high d low, the derivative of 3x is 3. So we can simplify this a little bit. In here, I want to save space. The x and the square, the x and the x, so that will leave 6 minus 3 ln x squared over 9x squared. Now we can find y prime when x is 1. This will be 6 minus 3 ln 1 squared over 9 times 1 squared, which is ln 1 is 0, 6 minus 0, 6 over 9, which is 2 over 3. Now the question turned to be very simple question. Find the equation of the line that passes through the point 1 and 0 with a slope of 2 over 3. So y minus the equation y minus y1, which is 0, equal m, which is 2 over 3, x minus x1, which is 1. This is the solution, this is the answer. This is the slope, and this is the point, and this is the answer. Okay, this is example 4. I want to give you one more example. Example 5 says f of x equal square root of x minus ln x. We need to find the values of x where the tangent is horizontal. Find x where the tangent is horizontal. The graphical meaning of this is a curve. I don't know how it looks like, but probably it would be something like this. And there is a point where the tangent is horizontal, which is the minimum point, the minimum value for y. We need to find this point. What is x at this point? We know that horizontal line has a slope equal 0, and this is a tangent line. The slope of the tangent is 0, means f prime of x at that point will equal 0. So all we have to do, we need to find the derivative and equate it with 0, make it equal 0, and solve for x. This is our plan. So how can I find the derivative of this? I will rewrite this in a way that I can find the derivative of square root of x is the same thing as x to the power of 1/2 minus ln x. So f prime of x will be 1/2 x to the power of negative 1 over 2 minus 1 over x, the derivative of ln x, which is the same thing as 1/2 1 over 2 square root of x. I send this down and I change it to radical form, minus 1 over x. Now we need to solve for x. So 0 equal 1 over 2 square root of x minus 1 over x. send this to the other side and cross multiply. So I know that, let's do that. So this is the same thing as 1 over x equal 1 over 2 square root of x. That means x equal 2 square root of x. We square both sides. So x squared equal 4x. This is a quadratic equation. In order to solve it, we need to have a 0. By the way, I cannot divide by 0 by x automatically, because if x is 0, I'm dividing by 0. So unless I have x actually is out of the domain because I cannot find ln of 0, but we didn't mention that x cannot equal 0. So when we come to here, we have to solve it as a quadratic, not to cancel the x's, because there is a possibility of dividing by 0, which is not allowed. So x squared minus 4x equals 0. X out, x minus 4 equals 0. So either x equals 0 or x equals 4. X equals 0, not valid, because if I put 0, I cannot find ln of 0. ln of 0, you know, ln function is like that. X has to be greater than 0. So this is not valid. The answer is x equals 4. So the curve will have a horizontal tangent at x equals 4. This is our answer. Okay. We done enough examples, so now it's your turn to do the homework that I will assign, and then ask me questions so I can do another video answering your questions. Have a great day. Bye.